Hello everyone, myself Nisarga, studying in Sri Venkateshwara College of Engineering. Today we discuss about concurrency control in database. Definition of concurrency control. Concurrency control is a technique used in database management system to manage simultaneous access to data by multiple users or transactions. Its primary goal is to ensure that transactions execute correctly and maintain data consistency. Despite being executed concurrently, concurrency control mechanisms prevent conflicts that can arise when multiple transactions attempt to access or modify the same data simultaneously. Importance in database system. Data integrity. It ensures that transactions are executed in a way that maintains the consistency and integrity of the data. Without concurrency control, simultaneous transactions could lead to inconsistent or incorrect results. Isolation. Concurrency control ensures that each transaction is isolated from others until it is completed. This prevents transactions from interfering with each other's intermediate status, which could lead to inconsistencies. Performance. While ensuring data integrity, concurrency control also aims to maximize the system's performance by allowing multiple transactions to execute concurrently whenever possible. This helps in utilizing system resource efficiently. Scalability. Concurrency control mechanisms are essential for scaling database system to support a large number of users and transactions. They help prevent bottlenecks and maintain system responsiveness as the workload increases. Impact of concurrency control on system performance. Increased locking overhead. Lock-based concurrency control mechanisms can introduce overhead due to the need to acquire, release, and manage locks. This overhead can increase as the number of concurrent transition and granularity of logs increases. Reduced throughput. Concurrency control mechanisms, especially those that serialize transactions, can reduce the system's throughput by limiting the number of transactions that can execute concurrently. These can lead to increased response times for users. Increased latency. Contention and conflicts can increase the latency of transactions as they may need to wait for other transactions to release locks before proceeding. This can lead to slow response times for transactions, especially during periods of high concurrency. Deadlock overhead. Deadlock prevention and detection mechanisms can introduce additional overhead as the system needs to continuously monitor and resolve potential deadlocks. The overhead can impact system performance, especially in complex transactional environments. Resource utilization. Concurrency control mechanisms can impact the utilization of system resources such as CPU and memory, as they may need to be used more intensively to manage concurrent transactions and maintain data consistency. Scalability challenges. Concurrency control mechanisms can introduce scalability challenges, especially in distributed database systems where coordinating transactions control multiple nodes can be complex and introduce additional overhead. Overall, while concurrency control is essential for ensuring data integrity and consistency in database systems, it is important to carefully design and implement concurrency control mechanisms to minimize their impact on system performance. Real-world examples of concurrency control in popular database systems. Database. Oracle uses a combination of techniques including two-phase locking and multi-version concurrency control (MVCC). It employs raw row-level locking to manage concurrency, allowing multiple transactions to access different rows of a table concurrently. Oracle also uses a read consistent view mechanisms to provide consistent query results even when data is being modified by other transactions. Microsoft SQL Server. SQL Server uses a locking mechanism for concurrency control including shared logs for reading and exclusive logs for writing. It supports multiple isolation levels, example, read committed serializable to control the visibility of data changes to different transactions. MySQL uses a variety of concurrency control mechanisms, including locking and multi-versioning. The default storage engine for MySQL uses MVCC to manage concurrency, allowing for consistency reads while writes are occurring. Conclusion. Throughout this presentation, we have explored various concurrency control techniques, including lock-based mechanisms, timestamp-based approaches, and optimistic concurrency control. And each technique has its advantages and limitations, and the choice of technique depends on factors such as the application's concurrency requirements and performance considerations. In conclusion, concurrency control plays a vital role in ensuring reliability and performance of database systems by efficiently managing concurrent access to data. Concurrency control mechanisms enable database systems to maintain data consistency, handle multiple transactions efficiently, and support scalable and reliable applications. Thank you for watching.